Welcome to Beyond the Comfort Zone Talking Shit with King-KAMBUF. Today, we are really strapping in for an intensive strategic planning session.
We really
We're
are.
taking a deep dive into the absolute foundational rigor of the Integrated Master's to PhD program at the Design and Build School of KING-KAMBUF.
That's right. And this isn't, just a schedule review. This is a dissection of the systems thinking required to manage massive, complex projects.
Okay, so what's the source material for this?
It's the Strategic Weekly Integration Brief for a course called DBX 501. And we're looking specifically at the Sunday Week Ahead Outlook module.
And this is what sets the stage for the entire week.
It sets the stage for a really intense cycle, this one from December 1st to 7th.
The moment you look at this curriculum, you realize the mission is just, well, it's incredibly ambitious. They're training what they call the Master Architect Builder Statesman.
Right, it's a mouthful, but it's accurate.
And our job today is to unpack that blueprint for you, to show you how they force students to get this seamless, non-siloed integration across 10 vastly different professional knowledge strands.
And this is all before the design work even officially begins on Monday. That's the key.
Right.
And that Sunday preparation, it's the linchpin. The whole idea, the fundamental hypothesis of the program is that preparation leads to synthesis, which then leads to successful execution.
So if you mess up Sunday morning,
If that alignment fails on Sunday morning, the entire 6-year sequence, it just risks total incoherence. So for you, the listener, you need to understand that this deep dive is about system alignment, not just, checking off tasks on a list.
okay, let's unpack this blueprint. We have to start with the foundational system. What makes this program actually tick? It seems to be this rigid, cyclical rotation they've built.
Yeah, they call it the machine.
Which sounds about right.
And it is. The required weekly cadence, as it's defined in the DBX 501 brief for all cohorts, is exceptionally purposeful. It's the scaffolding that prevents what they call disciplinary drift.
Okay, so most programs, they divide the week by subject matter, right? You do structures on Monday, history on Tuesday. KMBUF does it by function. Monday through Thursday are the input days, the core strand rotations where you're gathering specialized knowledge, structures, building science, planning, and so on.
That's your data acquisition phase.
Exactly.
But the real strategic power, it lies in the back end of the week. Friday is the integrator day.
So that's where you pull it all together.
You have to. All those specialized inputs, they have to be reconciled and mapped back to the studio design. Then Saturday is a review, where you assess the week's work, you identify failures, successes.
And Sunday, that's our focus today, is the outlook and preparation.
Yes, that's where you proactively align the mental model. You make sure that Monday's studio module starts with a unified, risk-mitigated plan.
It sounds absolutely exhausting, but I guess it has to be necessary. But I have to ask, doesn't this rigidity, doesn't it stifle creativity? The pressure to synthesize 10 strands before you even start the main studio work,
Yeah.
it just seems designed to constrain the architect side of that whole equation.
That is a critical question, and the source actually addresses it by defining the boundaries as the creative challenge.
Okay, so the box is the inspiration.
In a way, yes. The rigidity forces precision and what they call anticipatory design. The constraint isn't the schedule itself. It's the legal framework, the financial framework, the ethical framework that must guide the design.
I see.
So the system trains the student to find creativity within those very tight constraints. The Sunday prep, therefore, it's really just about establishing the non-negotiable boundaries up front.
That makes a lot of sense. We're
Okay.
moving from this idea of the lone genius architect to a highly integrated conductor.
That's a perfect analogy.
The visual aid they use in the sources, this spiral of integration, it captures that perfectly. It's the anti-silo mechanism, right?
Mhm.
It shows how 10 diverse knowledge strands all have to feed into that one central studio focus.
And we should probably list those 10 strands again, just because the complexity is staggering.
Let's do it.
You have studio, which is design, then structures, building science, civil and site, planning, which covers zoning and policy,
Yeah.
public administration, or PAD, construction management, or
Yeah.
CM, codes and ethics, digital, and finally, research.
And the inclusion of public administration, PAD, right alongside core engineering, that's where you start to see that statesman component really emerge.
Absolutely.
So how does this spiral actually prevent siloed thinking in practice? I mean, if I'm a student deep in structural calculations on a Tuesday, how am I forced to think about a public administration governance chart?
Because the preparation on Sunday mandates linking those inputs. It's not optional.
So it's baked into the process.
It's baked in. If you choose a structural system, let's say a steel moment frame based on the ASCE 722 seismic requirements,
Right.
the prep work demands that you simultaneously populate the cost placeholder in the CM strand, you identify potential regulatory conflicts in the code strand, and you check the zoning envelope in the planning strand.
So every decision has ripple effects.
Every single one. The spiral means no decision in one strand is ever isolated. Every technical input immediately carries a cost, a regulatory, and an ethical obligation that has to be tracked back to that central studio focus.
That system of interlocking obligations, that sounds like real professional practice.
It's designed to be.
So let's look at the measurable outcomes of this Sunday effort. The learning objectives aren't just, things to learn. They're described as the 5 pillars of preparation the student has to master in those 90 to 180 minutes.
Precisely. They transform preparation from just passive reading into active system alignment. The first pillar is pretty simple, mapping modules to strand rotation logic. Basically, identification. Know where you're going and what knowledge bucket you're trying to fill.
Then the second and third pillars are all about logistics. Preparing readings and code references is the mandatory technical pre-work,
Right.
and then allocating time effectively for design, analysis, and writing. That's the scheduling discipline. I'm guessing this is where techniques like time boxing are first implemented.
Oh, absolutely. Given the sheer volume of work, unrealistic time allocation is just a guarantee of failure. This objective requires the student to move beyond a simple to-do list and into realistic resource management.
Using things like batch drafting.
Exactly. Batch drafting grouping similar tasks, like writing all your analysis summaries into dedicated blocks. It minimizes the overhead from context switching.
Then you have the fourth pillar, setting measurable weekly targets, formulation. This forces quantifiable success metrics, doesn't it? So it's not just work on the design, but it's achieve confirmed massing and a preliminary structural grid decision by Monday at 5 p.m.
Yes. And that's crucial. Success isn't measured by effort. It's measured by achieving defined decision points. If the student can't define their targets clearly on Sunday, they can't be held accountable on Saturday's review day.
And that brings us to the final pillar, which, as we noted, is maybe the most defining characteristic of this statesman training. Integrating ethics and public good considerations into all strands.
Embedding.
Right, embedding them. This means ethical concerns aren't some final layer of polish you add at the end.
No, they are a foundational assumption, a constraint. If you're preparing your civil and site-based plans on Sunday, you must embed public good considerations, things like equitable access or resilience against climate change, directly into those site decisions.
So you have to justify your technical choices on ethical grounds from the get-go.
Yes, the system forces you to. It ensures that the structural, the energy, and the site decisions are inherently tied to broader societal impact.
That's a huge takeaway for any field, really. Ethics isn't some separate policy manual you read once. It's a constraint, just like IBC Chapter 5, that has to be defined and planned for on day one.
Let's transition into the technical core of this. The 60-minute Sunday lecture, the breakdown of it guides us through the specific technical inputs that are required. After the intro from the 15-minute mark to the 25-minute mark, it's an intense mandatory code and standards prep session.
This is the moment where I think the listener realizes the level of detail being demanded here. We're talking about 40 pages of reading across 4 major very complex documents.
And you have to absorb it and understand it well enough to make decisions before Monday morning.
Right.
So we have to slow down and explore the implication of these specific readings, starting with the regulatory backbone, the International Building Code, the 2024 edition.
And the focus is specifically on Chapter 5, which is general building heights and areas, and Chapter 10, egress. Why, at this very early stage, is Chapter 5 prioritized over, say, Chapter 11 on accessibility or Chapter 16 on structural design loads?
It's because Chapter 5 sets the fundamental regulatory limits. It literally defines the size of the box you can build based on occupancy type and construction material.
So if you get it wrong...
If you get the maximum allowable height and area wrong, your entire massing decision on Monday, and therefore your entire structural and mechanical system, is obsolete. It's a non-starter.
And the source materials really emphasize this.
They do. They note Chapter 5 is mapped to the PA programming and analysis and PPD project planning and design divisions of the ARE precisely because it dictates feasibility. If the code says you can only build 60 feet tall and the student plans for 80 feet, the week is a failure before it even begins.
It's pure risk management. You define the regulatory envelope first.
Yeah.
Okay, so once that's established, we immediately jump into high-level engineering constraints with ASCE 722.
Right, and the focus there is on chapters 12.2 through 12.5, which governs seismic system selection.
This forces the student to commit to structural assumptions really early, or at least to anticipate them.
It does. Are we dealing with a structure that relies on concrete shear walls, a steel moment frame, braced frames? The choice of that lateral system dictates the column grid and the overall architectural flexibility.
And what are the immediate cost implications of that decision before you even run the calculations?
Oh, they're huge. A moment frame gives you a lot of flexibility, but it's often the costliest and most complex system to detail. A shear wall system is highly efficient structurally and financially, but it severely limits your open plan architecture.
And the Sunday prep requires you to see that trade-off.
The Sunday prep requires the student to identify these trade-offs and ensure the structural choice aligns with the initial cost placeholder in the CM strand. They have to think about dollars and design flexibility at the exact same time.
Okay, so the box is defined, the skeleton is chosen. Next up is performance, IECC 2021.
The International Energy Conservation Code.
And specifically C402, which is envelope, and C403, which is mechanical. This moves us into energy on long-term operating costs.
Right, and the IECC section connects the code compliance directly to the building science strand. The student has to use their climate zone data to preemptively select envelope assemblies, wall, roof, glazing systems that meet the prescribed U values.
Why that's so critical so early?
Because the envelope is the largest determinant of heat loss and gain in a building. Getting this wrong impacts the size of the HEC system from C403, which is a major capital expenditure item. If you plan for a poor wall assembly on Sunday, you guarantee an oversized, expensive mechanical system on Wednesday.
So the goal isn't just to read the code, it's to derive technical specifications from it that feed directly into Monday's design and Wednesday's analysis.
Exactly. And the final piece of reading pushes the student beyond just minimum compliance toward aspirational goals, LEE V4.1 BD plus C.
And importantly, the focus is only on the credit intents for energy, water, and site, not the full compliance checklist.
Yeah, that's a key distinction.
Why focus on the intent rather than the mechanics of compliance?
It's a strategic move. The program is teaching students to establish strategic goals first. They need to understand the why. Why should we reduce potable water use? Why pursue a dense, high-performance site?
So you internalize the goal first.
Only once the intent is internalized can the student effectively navigate the compliance checklist later in the week. The LT intent forces an ethical and performance mindset during the initial framing phase, which complements the IBC's more rigid regulatory framework.
This whole section just confirms that the 10 a.m. Sunday lecture isn't just informational.
Not at all.
It's a high-stakes, anticipatory decision-making session that basically determines the success trajectory of the entire week.
Once those foundational codes are mentally mapped, the lecture then shifts around the 25-minute mark into execution strategy. How do you pace the work and build the weekly work block efficiently, given these 10 demanding strands?
This is where we see the techniques to combat that disciplinary fragmentation we talked about. The strategies mentioned, time boxing, batch drafting, and defining dedicated analysis windows, are essential for high-volume intellectual output.
Time boxing is just crucial for preventing scope creep. If you give structures 2 hours on Tuesday, you stop at the end of 2 hours. It doesn't matter if the calculation is perfect. You move on.
And batch drafting is pure efficiency.
It is. Instead of writing 4 separate emails or analysis summaries throughout the day, you schedule one block to handle all similar output tasks. You minimize the mental cost of switching context.
And the tactical output of this strategic planning is the design-to-delivery integration checklist, the explicit list of tasks that are due for each strand.
This is where you see the connections made visible.
Let's walk through the synchronization, starting with studio and structures.
Okay. Studio's pre-work is confirming design massing for Monday. This is totally dependent on that IBC Chapter 5 analysis.
Right.
Simultaneously, structures requires reviewing structural system possibilities. These two decisions are completely locked together. You can't mass a building without knowing its size limits, and you can't commit to a system without knowing the massing.
And this structural decision is so critical because it ties directly to the ARA, to PDD project design and documentation. Establishing the column grid and the lateral system assumptions, that is the definition of integrated design. If the structural team hasn't committed to a 25-foot column grid on Sunday, The studio designer risks drawing walls in the wrong place on Monday.
Then you move to building science MEP and envelope. That requires identifying envelope assemblies that meet climate zone U values. We talked about how this links to an ARE question about improved envelope energy planning.
And this forces an immediate integration with the digital strand, right?
Immediately. It likely requires prepping scripts for thermal analysis tools like Therm or Ladybug Honeybee based on these very assemblies you just selected.
The moving outside, civil and site demands. Preparing the site base and utility paths. This is linked to RCE construction and evaluation because it requires gathering crucial right-of-way data and utility maps.
And I imagine that's a point of frequent failure in early design.
Oh, it is. If you don't know the capacity, the depth, and the location of the municipal sewer line or the incoming power conduit, any site layout or foundation decision you make is just guesswork.
It's huge risk.
The Sunday preparation forces the student to stop relying on generic assumptions and actually gather verified utility data, which impacts grading, foundations, cost, everything.
Now we get into the administration and policy zone. Planning and policy requires gathering policy documents, zoning, the comprehensive plan.
And this is flagged with an immediate high-stakes risk. Unclear zoning assumptions.
An unclear zoning assumption is a project killer. It's that simple. It undermines the entire IBC Chapter 5 analysis. If the zoning map says commercial, but the student assumed mixed-use residential, the entire program is invalidated.
And then, the highly strategic step under public administration, PAD. Downloading AHJ governance charts. The authority having jurisdiction.
Yes.
I challenged this point earlier. Why is understanding bureaucracy so crucial on a Tuesday or Wednesday?
Because the governance chart is the bureaucratic map. It defines the critical path for approvals. Think of it as a risk register for timing and sequence.
Okay, so it's not just about what you build, but who you have to talk to and in what order.
Exactly. If you misread that chart, you might spend 3 months designing for a planning board review, only to find out that the final height variance you need requires a separate, politically charged zoning board of appeals hearing that only meets once a quarter.
Wow.
The statesman has to anticipate bureaucratic sequencing, not just technical sequencing.
That shifts the designer's responsibility from drawing beautiful buildings to designing a successful approval process. It minimizes costly surprises.
It's all about minimizing surprises. Then we have construction management, CM, which has to update preliminary cost placeholders based on the structural and envelope choices you made moments earlier. Every technical decision has a dollar sign attached that has to be tracked weekly.
Codes and ethics requires building or updating the code matrix for quick reference. This is the central repository, a summary of all the IBC, IECC, ASC decisions. A living document.
Yeah, a single source of truth that ensures rapid adherence during those high-pressure work blocks.
And, as we mentioned, digital requires preparing software scripts, Grasshopper, Python, Revit families, linking to an ARE question on automation.
Right, the student has to ensure their parametric massing scripts are ready to run iterative analysis on Monday morning, maximizing the use of that very limited time.
And finally, research, the doctoral methods part, requires organizing research notes.
This just ensures that the academic inquiry, the PhD track, remains integrated and actually informs the technical decisions rather than becoming this parallel, detached exercise.
Let's dedicate some serious time to the preemptive warnings. The source provides 5 high-stakes risk flags, treating them as actual project hazards.
And they're almost a mirror image of the checklist failures.
They are. They are the guaranteed failure points if the Sunday prep is incomplete.
Exactly.
The first, unclear zoning assumptions, we've established as the threat to basic legality and project massing. The second, unverified site utilities, threatens constructability and foundational costs. But let's look at the operational risks, incomplete energy assemblies, and late structural system decision. What happens to the project on Wednesday if that structural decision is delayed until Tuesday afternoon?
That's a classic systems failure, a cascade failure. If the structural system decision is late, it means the column grid is unstable. If the column grid is unstable, the MEP system cannot be accurately sized or routed, which delays the building science strand.
And if MEP and structures are delayed?
Then the cost placeholders in CM become highly unreliable, and the integrated code matrix is incomplete. A single failure in sequencing cascades into total synthesis failure by Friday.
And the fifth flag, misaligned cost model. This brings us right back to finance. If the technical decisions, say choosing an overly complex seismic system, are made without immediate cost feedback,
The financial model is compromised.
Right, which risks scope creep and requires value engineering later in the week, which is always painful and inefficient.
It's striking when you lay it all out. The Sunday Outlook is essentially the required documentation showing how the student has proactively eliminated these 5 hazards before drawing the first line. If a risk flag is still red on Monday morning, the student has failed the preparation phase.
So this intense preparation, it all culminates in a tangible, assessed assignment, the week ahead workbook. It requires 90 to 180 minutes of focused effort.
And this workbook is the final deliverable. It's the proof of successful system integration.
The assignment brief details 3 required steps that translate the conceptual alignment into hard data. First, create the weekly Gantt chart, sequencing all 10 strands.
That's your macro-organizational spine.
Next, they move to the micro detail. Adding reading pages and code chapters to the schedule ensures that technical inputs are tracked. But the most revealing step for me is populating specific design tasks.
Yes, the deliverables have to be concrete. You have to define the target for Monday's massing, Tuesday's structural grid, Wednesday's required loads, Thursday's site section details, and Friday's integrator outline.
So it forces the student to define success metrics, not just for the entire week, but for every single day within every single strand.
And finally, filling the cost and codes matrix. This acts as the singular source of truth, a consolidated database of every key assumption made on Sunday, from the IBC occupancy type to the dollars per square foot for the roof assembly.
And the deliverables themselves, they emphasize digital fluency and concise communication. You have the detailed workbook in Excel, a visually clear PDF dashboard for rapid review, and those prepped software scripts.
Exactly.
Now, let's analyze the rubric, because the scoring breakdown tells us everything about the program's philosophical priorities.
Right. The weighting is very revealing.
The grades are weighted across 4 categories. Design and tech is 40%, codes, performance, and cost is 25%, research and communication is 20%, and ethics and community is 15%.
What stands out immediately is the overwhelming focus, 65% on technical execution and adherence. That's design tech plus codes performance cost.
So the program values technical mastery above all else.
It does. However, let's look at that 15% that's dedicated to ethics and community.
15% is a substantial weighting for a non-technical sort of qualitative element in a technical program like this.
It is.
It means you can be a perfect engineer and still score poorly if your design neglects the public good.
Exactly. This 15% forces accountability. The student has to demonstrate, through documentation within the workbook, how ethical considerations inform their choice of, say, low-impact development strategies in civil site.
Or how material selection impacted embodied carbon.
Right, which is a key community and performance metric. It has to be woven into the deliverables themselves, which makes ethics quantifiable and mandatory, not just a nice-to-have.
So to manage this workload, the list of required tools of the trade is equally rigorous. We have the design staples, Revit, Rhino, Grasshopper, QGIS for geospatial data, Bluebeam for digital code review. But I want to spend a moment on the specialized analysis software.
This list is highly indicative of the program's performance mandate. We are moving far beyond simple conceptual design.
Really?
They require expertise in Ladybug and Honeybee and Energy Plus for detailed environmental simulation, Therm for complex thermal bridge analysis, and Tally for life cycle assessment.
Okay, why is Tally, the LCA software, so crucial for Sunday prep?
Because Tally assesses the embodied carbon of material decisions. It's the environmental cost of manufacturing and transporting the steel, the concrete, the wood you're using.
So when the student makes their structural and envelope material choices on Sunday,
Tally immediately provides a metric that impacts that ethics and community score. The program is forcing them to see material choices not just as cost and performance variables, but as climate variables tied to long-term public good. And the Excel workbook is the hub connecting all these disparate software outputs.
this planning is not just an academic simulation, it is licensure preparation. Let's look at the ARE thread mapping provided in the source. This 1 week covers PCM, PJM, PA, PPD, PDD, and CE.
It's nearly every division of the architect registration examination. It's all touched by this one Sunday preparation.
And the questions they provide really connect that preparation directly to professional practice. Consider this one. What is the best weekly action to reduce scope creep?
And the answer is early alignment of deliverables. That's PCM and PJM practice management and project management.
It just reinforces that the time you spend verifying zoning and utility data on Sunday is a direct investment in project profitability and efficiency.
Or what is the most foundational code chapter early in the week?
IBC Chapter 5.
IBC Chapter 5, which is PA and PPD. This reaffirms that the regulatory limits dictate all subsequent design and documentation moves. The preparation method is the professional method.
It seems like these connections ensure the learner understands that their 90 to 180 minutes of Sunday prep isn't simply a hurdle to jump over.
No, it's learning the crucial professional method used by the services of KING-KAMBUF PS Architecture Design Studios. It's managing risk, ensuring compliance, and preventing economic failure in the real world.
This final section, this really completes the training of that statesman we keep talking about. We're transitioning from ensuring the technical design is compliant to ensuring the financial and ethical dimensions are publicly defensible.
And the synthesis is what elevates the graduate. The section on public good and stakeholders forces the student to look past the building boundary and see the project's wider societal impact.
The questions are deeply challenging. Like, who benefits from the design decisions? If the building maximizes profits for the owner, but displaces long-term residents through increased rents, that has to be acknowledged.
And critically, how are vulnerable users considered in site and street planning? This connects the civil site strand directly to equity. Are the pedestrian pathways safe? Are delivery zones and utility paths managed in a way that doesn't compromise public access or neighborhood safety?
So the design has to be actively supportive of equity, not just passively compliant.
Yes. And the mandate. Where do equity measures show up in massing, access, and performance? This forces the student to trace that ethical commitment into the physical form. Does the building massing cast shadows that negatively impact public space or solar access for adjacent affordable housing?
The ethics checkpoint summarizes the core requirement here. All decisions must be explainable, documented, and publicly defensible.
And documentation is protection. If a decision is challenged, say the choice of a less sustainable but cheaper structural material, the student must have the transparent documentation that justifies that trade-off against the stated ethical objectives.
Okay, shifting gears, let's talk money. Because ethics often hits reality hard when costs are involved. The required mini pro forma, a 12-line financial summary in US dollars per square foot, must be integrated into the Sunday preparation.
Right. Show me the money and show me how my design choices impact it.
This is where the engineering decisions meet the budget ledger. The total CapEx, the capital expenditure, is defined at $288 per square foot. We can analyze that allocation to understand the program's emphasis.
Let's break it down.
Okay, we see structure at $44 a square foot, envelope at $52, and MEP at $48.
So it's $144 out of the $288 CapEx dedicated to just 3 technical systems.
All of which are the subject of that intense focus during the Monday to Thursday rotation.
It validates why the IBC, ASCE, and IECC code prep is mandatory on Sunday. These divisions carry half the financial weight of the entire project.
And the program requires students to understand the necessary project buffers. Soft costs are $24 a square foot.
That covers your fees, permits, financing.
And contingency is $13 a square foot. That's the money set aside for the unexpected.
And the goal of Sunday planning is to protect that $13 contingency by eliminating all the known risks before you start.
We also see the long-term focus with operational costs, OPEX, at $9.10 per square foot per year.
Right. A high-performance envelope planned on Sunday reduces OPEX, which provides long-term financial viability that benefits both the community and the owner.
But the strategic instruction here is maybe the most advanced element of this statesman training. Explore value capture for site and infrastructure alignment.
This is pure planning and policy synthesis.
That goes so far beyond just designing a nice building. What does value capture even mean in this context?
It means maximizing your return through synergistic public-private investment. For example, if the student designs the civil and site preparation to align with a planned municipal infrastructure upgrade.
Like optimizing utility paths or dedicating land for a public greenway.
Exactly. They might unlock zoning bonuses or tax incentives or infrastructure funding that increases the project's financial return without increasing the developer's private capital outlay. It's about leveraging that public administration knowledge to enhance project finance.
That's the difference between a high-paid designer and a master planner. They're leveraging policy to maximize financial health.
And finally, the Leadership Minute summarizes the core mandate of this whole Sunday session. Leadership is defined as framing.
Framing defining boundaries, constraints, and success metrics before the work starts.
The leader defines the non-negotiables, the budget target, the structural system assumptions, and the ethical constraints, like minimum energy performance standards. If that frame is clear on Sunday, the team knows exactly where to apply their specialized knowledge during the week.
The PAD and ethics stance also mandates transparency and leadership, it says. Articulate assumptions early, publish the decision log, hold to transparent metrics, and critically, create room for dissent.
That mandate to create room for dissent is so essential for complex projects. If the structural engineer sees a major seismic risk in the planned massing, the published decision log must be transparent enough to allow that challenge to surface quickly.
Instead of being buried until it's too late.
Exactly. Accountability isn't a burden. It is the protection that ensures the professional avoids ethical and financial catastrophe.
What an immense system. From Chapter 5 of the IBC all the way to Tally LCA software, and then to a 12-line financial pro forma, the entire project lifecycle is compressed into a 180-minute Sunday planning session. The core takeaway is that preparation isn't about avoiding work. It's about establishing a robust system that minimizes risk, maximizes ethical performance, and ensures that 10 specialized tasks move forward as one single coherent project.
The weekly outlook transforms a collection of tasks into a truly integrated effort. It achieves system alignment before the first design decision is even locked in.
So let's bring it back to the most immediate consequence of this planning failure, the money. We established that the total CapEx is $288 a square foot, with a critical $13 a square foot contingency buffer.
The safety net.
Exactly. So based on our discussion, if you fail to address one of those 5 high-stakes risk flags during Sunday's planning, which one, unclear zoning, unverified site utilities, incomplete energy assemblies, a late structural decision, or a misaligned cost model, which one poses the greatest financial threat to that $13 contingency?
That's the question that defines the strategic planner, isn't it? Is it the unknown utility path that busts the site budget? Or is it the delayed structural decision that forces costly redesign and scheduling penalties down the line?
You have to think about the multiplier effect of planning failure on economic outcomes.
Something to mull over as you prepare your own week. Thank you for joining us for this intensive look into the strategic systems thinking of the Master Architect Builder Statesman training at KMBUF.